Hello everyone. Today we will study how the energy band are formed in solid. So, basically in case of solid there are huge number of atoms, but if we consider only one single atom, suppose the isolated atom, if we consider one isolated atom, then consider this one. So, this one is nucleus, we know center nucleus is there, and centering this nucleus the orbits are there, and this orbit, in this orbit electrons are there. So, suppose if we consider the silicon atom, then we know the atomic number of silicon is 14. So, the energy distribution of electron is like this, that is 1s2, 2s2, 2p6, 3s2 and 3p2. So, in this way first orbit, second orbit, third orbit, the electron distribution is this way. But in what happened in case of isolated atom, there is no interatomic distance because there is no other atoms are there. So, what will be the energy distribution of this electron? In case of isolated atom, when the interatomic distance is very large, that means you can consider no interatomic distance are there, the energy level of this type of electron are shaftly defined, say 1s2, 2s2, 2p6, 3s2 and 3p2. So, these energy level are shaftly defined. But what happened when we consider the energy distribution of electron in solid? Because in solid there will be a large number of atom and the interatomic distance of solid is very less. So, we have to consider the interatomic distance is very less in case of solid. So, suppose this is the structure of silicon solid, where the outermost, there in case of isolated atom also we can see in outermost orbit there are 4 electrons are there. So, to complete the vacancy of valency of this last orbit, this silicon atom should consider 4 more electron to fulfill its valency, but only 4 electrons are available in the last orbit. So, to complete the valency of these 4 electron, this neighboring electron will make this covalent bond, where this electron, particular this electron or this electron will be shared by own and the neighboring atom also. So, this electron will be shared by this silicon as well as the nearest one, that means this one. In the same way, this electron will be shared by this atom and the neighboring one. So, like this way the electron will be shared by its own and the neighboring one. So, what happened in the energy distribution of this solid? So, in case of solid, as I discussed, interatomic distance will be very less, and due to that the covalent bond will be formed to share the electron. So, basically the electron will be shared from the outermost energy shell, because all the electrons in the innermost energy shell are very strongly bound with the nucleus, and the outermost electron are taking part of this, making this covalent bond. So, the energy of this electron will only change. So, for silicon the last is 3s2, last orbit is 3s2 and 3p2. So, remaining 1s2, 2s2, 2p6 and 2p6 will be constant, there will be no changes in this 3 energy level. What happened in case of 3s2 and 3p2? Because the last energy cell last orbit is 3. So, the energy level of this 3s2 and 3p2 will change. Basically the energy level of this 3s and 3p will split. Now, why? According to the Pauli's exclusion principle, we know that the no 2 electron can share the same energy state. So, when this electron will be shared by its own nucleus and the neighboring one, then this energy of this electron will be split. Now, the question is in how many times it will split. Suppose if we consider total, there will be n number of atoms are there, constituent particle are n. So, if n number of atoms are there, then this 3s will split into n number. In the same way, if n numbers of atoms are participating, then same 3p will be split into n number of energy level. So, this is 2n. Why the capacity of this 3s is 2n? Because each s can occupy only 2 electron, each p can occupy 6 electron. So, together the hybrid energy level will carry 8n energy level. So, further if we want to decrease the interatomic distance, then what will happen? Further, when we decrease, this hybrid energy level will split into 2. The upper one is called conduction band and the lower one is called valence band. The energy total 8n will be distributed in 2 types, in 2 ways. 2 equal energy will be distributed, that is 4n will be in the upper band, 4 electron will be in the lower band. So, this is how the energy bands are formed in solid. Now, what is this? This is called forbidden gap. The distance, the separation, the gap between this conduction level and this valence level is called forbidden gap, and in this forbidden gap no electron can occupy. So, this is how the energy bands is formed in solid in case of silicon. So, if we consider germanium, the atomic number of the germanium is 32 and the last orbit is 4s2 and 4p2. So, in case of the energy distribution of germanium, we will see the energy level, that is 4s2 and 4p2 will split into 8n times. So, all the remaining one, that is 1s2, 2s2, 2p, 6 up to 3d10, it will remain same because these are inner, these electrons are situated at centering their nucleus, that are inner part of this level. So, 4s2 and 4p2 will split into n times. So, this one is also called a semiconductor device. But what happened in case of carbon? In case of carbon also, the outermost energy level will consider 4 electron, but this carbon, the atomic number of carbon is 6, but carbon is considered as an insulator. Why? Because in case of silicon also we say we can see that 4 electrons are outermost orbit. In case of germanium also 4 electrons are at outer orbits. In case of carbon also, but why carbon is insulator and this silicon and germanium are semiconductor? Because of this forbidden gap. In case of carbon, the forbidden gap is 5.5 electron volt, but in case of silicon and germanium the gap is very less, that is say 1.1 for 1.1 electron volt for silicon and 0.7 electron volt for germanium. So, because of this gap we can classify also a solid in 3 categories basically, that is metal, insulator and semiconductor. So, this is how energy bands are formed in solid. Thank you.